Hello and welcome to the first lecture of your final lab exam. Now, the first thing I want to say is this. This set of labs is over less naming material, if you will. There's a little less to know in the grand scheme compared to something like bones where there's literally millions of parts. But here in muscles and vision, the lab and the lecture are far more cohesive, and if we were person to person, we would be spending way more time doing work in the lab than we do, on the screen here. The idea is that we'd be spending far more time doing hands-on activities than just learning parts and pieces. Whereas we are not in person, ergo we can't do those labs doing hands-on activities. So we're just going to have to take our best shot at this and see where it takes us and hope for the best. So that's what we're going to do. Let's proceed. Now, the first lab to talk about here is indeed on musculature. And when we're dealing with musculature, a great place to start is on describing sort of how muscles are arranged, how we name them, and sort of how they do what they do. And you're going to find this is very similar to the lecture on this stuff, so just prepare yourselves. All right, here we go. Muscles, joints, and movements. Muscles move, so they all will have an origin and an insertion, in some cases more than one of these, okay? But an origin and an insertion, all muscles have these. An origin is a point that is relatively immovable when the muscle flexes, whereas the insertion point is movable. So in my bicep, as a good example of this, the origin point that doesn't move is way up here around my scapula, my humerus, the top of that. So what's happening is the muscle is inserted up here, and when I flex my bicep, like I can feel the tendon in there, okay? When I flex my bicep, this point doesn't move, it's an origin. Whereas the insertion point is way down here, okay? So when I flex my bicep, it pulls my arm too. Like that point moves when I flex the bicep. This point does not move when I flex the bicep. Origin, insertion. And that's how this goes. You can see this here. And I will say this as well, muscles come in just numerous different shapes and sizes, so you got all sorts of different types. And what we're really doing here is we're trying to balance out strength and distance of movement, and then occasionally some weird shapes and things we have to do, like your ocular muscles, like your orbicularis oculi, your orbicularis oris that will be around your lips. These muscles are basically set up to be able to close something and open them, like your eyes and your mouth. So they are circular in form, but most of the rest of these are set up as a balancing act between strength and length of motion. Like you look at a bicep. Here, all the fibers, if you had a bicep in your hand, you could look at it, you could almost peel it open. All the fibers run directly up and down. So I grab my model here. And of course, the bicep happens to be missing off of this one, but that's okay. Actually, yeah, it'll work. What we have here are muscles where all the fibers run in a single direction. And the reason that all these fibers run in a single direction is basically, if all the fibers are lined up, that muscle can shorten way more than if the fibers are coming in at some kind of weird angle like these pinnate muscles. Pinnate means feather-like in essence, so it looks almost like a feather. The fibers come in at these weird angles. When all the fibers are straight, the muscle can change great length. Your bicep can really change length. It can move over long distances. Whereas the muscles in your shoulder, like your deltoids, if you kind of feel your deltoid and feel how much they move, there's really not much in there. A lot of it's up in your scapula, changing the angle of your scapula. So the deltoid doesn't really move that much. And the reason for that is, if you can get all those fibers packed in at a weird angle like this, it makes the muscle very, very strong. So strong muscles per unit of area have their sarcomeres, their fibers kind of jammed in at weird angles like this or this, whereas muscles that have their fibers lengthwise tend to be able to contract over long distances. Like I say here, your bicep can change length by about 70%, so it can greatly shorten when necessary. Now, I feel like it's also important to talk about how we name muscles. It's a really good idea, a good place to start. Muscle locations, we certainly name muscles based off of their location. Bone or body regions with which muscles are associated, like your intercostals are a good example of this. Intercostals would be like between ribs. Intercostal, like costal cartilage of the ribs, right? Anything costal, think ribs. We have muscles between the ribs. These are intercostal muscles, right? Your muscle here right on your forehead is called your frontalis, because it literally is on the frontal bone of your skull. It makes perfect sense. Muscle shape. So something like deltoid as an example. If you know your letters, your Greek letters, a triangle, if you will, it would be a delta letter, if you will. Muscle shape. So deltoid muscle would be in your shoulder here. Let me see if our model has one. That would be in the shape of a Greek delta letter, if you will. And think about this as an upside down triangle, okay? Trapezius. So the trapezius muscle is supposed to be in the shape of a trapezoid. Like this is how we do this. It's really not that complicated. Muscle size, maximus being large, minimus being small, brevis being short, longus being long. None of this is that complicated. Direction of the fibers or fascicles. Rectus. Okay, so you have to imagine the body having like this imaginary line straight down the core of the body. And any muscles where the fibers run directly parallel to that line, we call those rectus muscles. So they are rectus muscles. The fibers run straight. So like your abdominis, or rectus abdominis, I should say. You have rectus femoris muscles. These are going to have their fibers running directly parallel to this imaginary line down the body. Then there are things like transversus muscles that kind of go the opposite direction. Oblique muscles that come in at oblique angles. That's how this works, man. Number of origins. Biceps. Anything seps means head. Seps means head. Like you may have heard, there's a condition that some newborns get called hydrocephaly, where cerebrospinal fluid isn't draining as well as it should. So the brain, well, I should say the skull kind of fills with fluid and it pressurizes it, makes the brain, or the whole skull, swell basically. Cephaly, hydrocephaly means water on the head or water on the brain. Anything cephaly, it means head. Where am I at? Origins. All right, biceps means two heads or 2 points of origin. Your bicep has 2 origin locations. Guess how many your tricep has? 3 triceps, 3 points of origin. Locations of attachments. Man, most of the muscles that I think of offhand do this. The classic example as I've got here is your sternocleidomastoid muscle. Sternum, clido, think clavo, okay, clavo. Mastoid goes all the way up to here. If you take your head and kind of pull it down at an angle, you can pinch this up, okay? One on the other side right there. So sterno, clavo, mastoid. It's easy. Brachioradialis. Take a wild guess where it starts. In the brachial region of the arm, guess where it ends. Brachioradialis ends on the radius. This is not rocket science. It's a very neat way to do this. And the idea is, if you've been paying attention up to this point, you kind of know your muscles and joints, your bones and joints. Learning your muscles is not going to be that complicated. Muscle actions. So we certainly name muscles for the way in which they function on occasion, like flexors and extensors are classic examples of this. So if I have my arm here and I bend it over like this, that action, that's flexion, okay? And then by comparison, if I run the opposite direction, that is extension. These muscles are called the flexors. Flexors ulnaris, flexors radialis, flexors adductors, or flexor longus, this kind of thing. By comparison, if I do this is extension. There's an extensor ulnaris, extensor radialis, extensor communis in the middle. Like all of these fit the naming methodology here. I think I have more. Yeah, pronator teres. So this is supination, this is pronation, and the muscle here that assists you with that twisting motion is called the pronator teres. And oftentimes we'll combine most of these together to come up with a naming mechanism. So something like extensor carpi radialis longus. Extensor carpi radialis longus. Extensor, it's going to be up there. Carpi comes down to the carpals. Radialis, it's over the radius. Longus, it's the long one. It's right there, okay? You can feel it inside your arm. That's how this works. It's a neat process. There are certainly functional groups within musculature. These are thought of as being prime movers, synergists, antagonists, and fixators. Prime movers, synergists, antagonists, and fixators. A prime mover is the muscle that does the majority of the job. So when I lift up my Taco Bell here, or I lift the clicker that allows me to control the slideshow, when I do this, the muscle that I'm using primarily is my bicep. My bicep in this case would be the prime mover. It's doing the majority of the work. Synergists are muscles that help. Okay, these are helpers. So when I do this action and I lift this up using my bicep, my brachialis muscle inside of here, it helps. It assists with that. It is a helper. It is a synergist, okay? Antagonists, they work against. They work in the opposition. When I lift something with my bicep, my tricep is mildly contracted and slows the activity down. It's a control mechanism. And so I can't throw this thing up through the roof when I flex my bicep. My tricep helps to moderate the action. It is an antagonist, okay? They're not working against one another per se. They're working towards a common goal, one of which is causing the muscles or the joint to become more flexed, and one slows that action down. Okay, your body's working together. It's not like they're against each other. But antagonist, triceps. And then last but not least, fixators. Man, you have a variety of fixators all over your scapula. If you look at the scapula here, it's just encased in muscle. Okay, encased in muscle, like the rhomboids inside of here, for example. And what's going to happen is whenever you lift your arm like this, all the muscle here in the shoulders just goes and locks everything down. They are fixators. They hold it all together very tightly so this arm can do whatever the arm has to do to get whatever motion you require. The idea is that your arm is almost free floating from the rest of the skeleton, but you have muscle all over your scapula that can lock it down, very popular, and allow you to do the movements that you need when necessary. And next we can do intrinsic muscles and extrinsic muscles. Intrinsic muscles are those which are contained within a region in which they work, and then, yes, intrinsic muscles contained within the region in which they work, whereas extrinsic muscles work outside of their region. So an intrinsic muscle example would be like here in the thumb, okay? I've got a muscle from there to there, and it controls that thumb and makes it functional. And then by comparison to that, extrinsic muscles act outside of their region. So when I run my fingers like this, the muscles that do this are all down here. These are extrinsic muscles. That would be an intrinsic example. Extrinsic versus intrinsic muscles. All right, flexion, extension, hyperextension, adduction and adduction, pronation, supination. I feel like we did these in lecture. I will run through them one more time. They're incredibly important, and you will be using these to answer questions on your lab final. The idea is you need to know the muscles, and you kind of need a grasp of what they do. Okay, you just need a grasp of what they do. For example, flexion and extension. If I put a star on a muscle here in the lower arm, you have to know it's a flexor because its action would be flexion. By comparison, extension. If I put a star on a muscle here in the arm, you have to understand that that's extension. Okay, so it's going to be an extensor. Like grasping this is important. You need to understand like your bicep would be a flexor, your tricep would be an extensor. Hang on, let me get this Durham arm tag off. This basically just says that I'm okay to be here today. The muscles in your neck on this side would be flexors. The muscles on the back of your neck, splenius muscles for example, would be extensors. They make you look up. That's how this works. That's how this works. We talked about the pronator teres. These actions, abduction, okay, to raise the arms up, adduction, to bring the arms back down. These actions and the names of these actions are very, very important for us. Okay, now then, let's talk about it. Same stuff. What we have is a nice model of the face and the upper neck. All right, front side. On this, there are some muscles that you need to know. If I don't talk about it, you don't need to know about it. And I have more on my PowerPoints than your book actually contains if we had the lab manual for this class. So I'm going to limit this. We're going to limit it just a little bit. So if I don't talk about it, you don't need to know about it. So let's get started. Now, as we do this, you'll see that I have a few blocks of text like this one here, these down here, this kind of thing over here, this and that. I want you to know these concepts. So not only do you need to know the muscles, you need to have a grasp of what some of them do. And I've made notes of the ones that I want you to be familiar with. Not all of them. Not all of them. Just the ones I'm pointing out to you. So let's get started. In the neck and the face, I think it's worthy for you to be aware of the orbicularis oculi and orbicularis oris. Orbicularis oculi muscles are just around the eyes. If I put a star on the muscles that surrounds the eyes, that's orbicularis oculi. Orbicularis oris, that would be around your lips, that's your mouth. By comparison, I would like you to know your masseter. This is the big muscle that allows you to chew through your jaw. The chewing activity that you do, mastication is chewing. You have this big muscle in your jaw that is used for chewing. And let's just skip sternohyoid and go straight for sternocleidomastoid, which is what I'm talking about here. Sternomastoid, sternocleidomastoideus. This muscle here, you can grab it right there, sternocleidomastoid. Right there, this is going to be a muscle whose origin is on the manubrium and its last insertion is on the mastoid process. And the idea here is that if both of these contract, that's flexion, and if one of them contracts, that kind of rotates the head. Okay, so you need to be aware of this. On all these muscles that I'm talking about, activities or actions, if you will, you need to think to yourself, how does it work? Okay, how does it work? What does it do to be functional? And if you look at that muscle and you kind of put a finger on your neck there and a finger down here on your manubrium, when you flex that muscle, pulls your head down and away. All right, good. Next, here we are in the chest. So on the chest, I want you to know about your pec majors, which are here, okay, pectoralis majors, and underneath that there will be pec minors, but neither here nor there for our conversation. Just worry about the pec majors. Don't worry about latissimus dorsi from this view. The latissimus dorsi is a back muscle, so we'll look at that when we do the back. Like I can flip this guy around, and you can see the latissimus dorsi on the back, and it kind of comes up underneath the arm there. So it's on both sides. It can cover both sides like a big sheet. Well, this is a bad example. I gave you Arnold on purpose here. There's a latissimus dorsi muscle. Yeah. So just ignore it from this view. I do want you to be aware of the serratus anterior muscles. Your serratus anterior muscles are like these finger-like projections in essence that come back here and connect on the scapula. So if I kind of take my hand and put it around the front of the arm there, my palm would be connecting to the scapula, and these finger-like projections would be parts of the serratus anterior. You can see them kind of sticking through here. It looks almost like fingers, and it's right in your armpit. And the idea is that when this muscle contracts, imagine it contracting and pulling the arm in. Okay? As it flexes, it pulls the arm in, and when it relaxes, the arm can go back out. The serratus anterior muscles have an origin on the upper ribs. Their insertion is on the scapula, and their action is to pull the scapula anteriorly. So if I have my arm out like this, when I contract my serratus anteriors, it pulls the arm in like so. And if you take your hand, you really dig into your armpit and you can feel those muscles flexing as you move. Okay, those are serratus anterior. Serratus anteriors give you your tennis swing, okay, or swinging a bat or something like that. That's serratus anterior muscles. What else do we want to do? Let's do some abdominal muscles. So what we have here is what it would look like normally. So this is the skin peeled away. If you just pull the skin away, what we have is what's referred to as a rectus sheath. It's this big layer of very thick white connective tissue on the outer surface of what would be the rectus abdominis muscle. Do I even have that labeled here? regardless, those are the rectus abdominis muscles, and you need to know that. I don't know how on earth I don't have that labeled, or either it is labeled and I'm not paying attention. Yeah, way down here, they have it labeled at the very bottom. But this whole thing is a rectus abdominis, but it would normally be covered by a thick sheet of connective tissue. Neither here nor there. So those are rectus abdominals covered by a thick sheet of connective tissue, and then that connective tissue kind of comes in and it connects to your external obliques. So the two sides of your body here and there, these are abdominal obliques, your external obliques. You can see this here, the external oblique, and then underneath that, if you kind of take the rectus sheath and you peel that back, you get your rectus abdominis underneath that. And as you peel it back, it opens up and the external oblique is removed. So you'd have an internal oblique and transversus abdominis muscles. And that's what they're trying to show you here. You can see the internal oblique and the transversus abdominis. I'm not as concerned with that at this stage. I'm simply pointing out that your muscles are in layers. What I would like for you to understand is that you do have these rectus abdominis muscles here, and when they contract, they kind of pull your torso down. The idea is the rectus abdominis has an origin on the pubic bone and an insertion way up on the sternum and the lower ribs, and its action is to flex at the waist, okay? And then your external obliques kind of help with that rotation therein, movement of the waist and twisting motions. Action of the external obliques is flexion and rotation at the waist. Okay, I realize we're kind of all over the place there, but I think you get my point. Knowing about the pectoralis majors is important. We talked about the latissimus dorsi, going to be on the back. We'll do that in just a second. We talked about the serratus anteriors and how they kind of function, and we talked about the rectus abdominis and the external obliques. Okay, good. That's perfect. So here is the back. And on the back, there are several muscle groups that you need to be aware of. The deltoid is actually in multiple pieces. Like it's shown here as a solid muscle, but there's a lot of individual parts and pieces therein. We're just going to call it deltoid. The delts, let's hold that thought for a second. So we're just going to call it deltoid. You have trapezius muscles that we oftentimes think of as being neck muscles. Do I have a bodybuilder on here by chance? No, you can kind of see up in here, this would be a trapezius muscles on Arnold's neck. This is all trapezius here on the back. And if we get our model man here, you can see the trapezius muscles there. These are considered back and shoulder muscles. So we have trapezius, we have deltoid. And then if you come down the back, what you end up with is this latissimus dorsi. Like all of this, all of that would be latissimus dorsi. So trapezius, deltoid, latissimus dorsi. Trapezius, deltoid, latissimus dorsi. Those are the main muscles for the back, the main ones. These are the most important. And then there are some others that are worthy of our conversation. Like, what do I want to talk about? Probably not a levator scapulae. Supraspinatus, infraspinatus. Here's the spine. There's a supraspinatus fossa and infraspinatus fossa. So I may throw a supraspinatus or an infraspinatus muscle on there for fun. The main ones I guess I feel like talking about, I don't even have scalenes on here, I guess will be the rhomboid muscles. The rhomboid muscles are the opposite of the serratus anteriors. So if your serratus anteriors are here on the front and they pull the arm like this, the rhomboids are kind of deep in the back and they pull the arm back like that. So if you rear back to punch somebody, your rhomboids are cocking that arm. And then if you actually hit them, your serratus anterior is pulling the arm forward. If your tennis swing is going to be serratus anterior, your tennis backswing is going to be rhomboids. They are, and this is a really important term, you got to know they are considered antagonistic pairs. Okay, they work in opposition to one another in theory. Okay, they are antagonistic pairs with one another. The serratus pulling the arm forward, the rhomboids pulling the arm back. Kind of like your deltoids and your latissimus muscles are. You can see the deltoid here. If the deltoid flexes, what it's going to do is it's going to pull the arm up like so. And then by comparison, your latissimus muscles are here, and what they do is if they contract, they pull the arm back down. Your deltoids abduct the arm, your latissimus muscles, like latissimus dorsi, pulls the arm back down. That is adduction. So abduction versus adduction. And I can definitely see asking that on a test. I could put a question like, what is an antagonist? What pairs antagonistically with your latissimus dorsi, deltoid? Name two muscles that work in opposition to one another, biceps and triceps. You see where I'm going? Like this is the kind of thing that I want. And again, the only actions I want you to be aware of are the ones that I have directly noted. So we got trapezius, we got deltoid, we got rhomboids, we got lats. And I mentioned supraspinatus and infraspinatus just because you have to learn the supraspinous fossa and the infraspinous fossa above and below the spine of the scapula. Okay, so your lab manual. Your lab manual skips most of the muscles in the arm, and I know that we're not using the lab manual, but I'm going to try to stick to its recommendation, and I'm going to skip most of those too. What I will point out, you obviously need to know your biceps and your triceps. This is not rocket science. You should know that you have a biceps and triceps already right now without going any further. On this, you can also see the brachialis muscle here. The brachialis, and then the first muscle there is called the brachioradialis. So brachialis, brachioradialis. And other than that, I want you to know that these on the outer portion of the arm would be extensors, and these on the underside of the arm would be flexors. So we got deltoids, biceps and triceps, brachialis, brachioradialis, extensors, flexors. Okay, let's stick to that. Now I also have biceps and triceps, origins, insertions, and actions here. That's fair game for your exam. Again, the way I would do this is I would put a star like here on the bicep, and I would say, identify this muscle, bicep. What's its action? Flexion. Where would its insertion point be? And you could say on the radius. Okay, and I'm trying to simplify this down as much as I can. You know, you get my point. So that is good enough for the arm. Again, biceps and triceps, you need to know your origins, insertions, and actions. Yeah, good enough. Let's go to the legs. Now, your book has a little bit more on the legs. In particular, the upper thighs are very important for us here, and I will mention just a few things about the legs on the lower side, and then we'll do a knee joint and call it a day. All right, let's do the legs. So on the legs, important to point out, let's just start on the left and work our way down. We got a tensor fascia latae here. You can see this on this model. It's kind of like on the side. And what it does is, it is the tensor, a muscle, which contracts and puts tension upon this fascia of latae that surrounds the quadriceps. So you know that if you've got a muscle or muscle group that's causing you issues, one of the things you might do to take care of this is to wrap it in like an ACE bandage. This is an ACE bandage built in. It supports the quads. This is the tensor of the fascia latae. The fascia latae being a connective tissue that surrounds the quadriceps muscles. Tensor fascia latae. The quadriceps, well, hang on. Let's do quads and then we'll do sartorius. The quadriceps muscles themselves, of which there are 4. I'm really concerned with you knowing 3 of these, but they are the rectus femoris, the vastus lateralis, and the vastus medialis. And the way this works is as follows. The rectus femoris would come down over the top of the leg, as you can see here. Okay, rectus femoris. Now this would be lateral, this would be medial. The vastus lateralis would be there, the vastus medialis would be there, and then underneath all of that would be what's called a vastus intermedius. And the vastus intermedius is like if you took off the rectus femoris, you would be looking right at the vastus intermedius underneath that, which they have kind of tried to do here. Underneath the rectus femoris would be the vastus intermedius. Now, the rectus femoris has an origin on the ilia of the pelvis, an insertion on the patella or tibia, and this is kind of complicated, and then its action is to extend the knee. So you can imagine, I've got my nice knee model here. Pay attention. Tendon of the rectus femoris, patella, patellar ligament. Rectus femoris tendon, patellar ligament. What will happen is if the leg is bent and you contract your rectus femoris, what it will do is it will cause the leg to become straight. that action is to extend. That is to extend the knee. To extend the knee. All right. Now then, let's talk about the thighs. Actually, let's not. Apparently, we don't go into that much detail on them, so I'm not going to make you go into that much detail on them. We will, however, point out the sartorius. The sartorius is a very easy muscle to see. It's this big, long strip all the way from the hip down to the knee. This big strip goes all the way through. There's actually several important muscles all deep inside of there, but let's only worry about the sartorius for time being. So we've got tensor fasciae latae, we've got the sartorius, we've got the quadriceps muscles and their names. That is all upper thigh. On the back side, no pun intended, we've got the gluteus maximus. Underneath that would be a gluteus medius and gluteus intermedius and a cauda femoralis, which you don't need to know. Just worry about the gluteus maximus. All right, worthy of mention here are the hamstrings as well. On the hamstrings, the way I like to do this is you get the biceps femoris going towards the lateral aspect, and then towards the medial aspect, it is the semitendinosus. And that's really all I am that concerned with at this stage. Now, the lower leg, again, you get your patellar ligament, your quadriceps tendon with the patella in the middle. What we have is a tibialis anterior, a gastrocnemius, and a soleus. And I guess we'll talk about the Achilles tendon as well. So let's run through these. If you take your hand and you feel the front of your shin, okay, that'd be below your knee, what you'll feel is a broad bony plate on the medial aspect, and then on the lateral, aspect, we have this muscle right out front. That muscle out front is called the tibialis anterior. Huh, it's amazing. Tibialis, it's by the tibia, and it's anterior, it's towards the front. Okay, tibialis anterior. The gastrocnemius, that is your calf muscle. Okay, your calf muscle is going to help you kind of point your toe, so to extend at the foot. Just ignore my action down here. I don't really like it as much as I used to, but the idea is the origin is, femoral condyles. The insertion is on the calcaneus via the calcaneal tendon, and its action is to extend the foot. Okay, to extend the foot. I guess that's what that means. Yeah, good. Now the soleus is just kind of behind the gastrocnemius. Don't worry too much about that. I will, however, talk about the Achilles tendon. So your calcaneal tendon or your Achilles tendon is indeed on the back of the leg, connecting down to the calcaneus. That would be your heel bone. And when you contract your gastrocnemius muscles, this would be your calf muscle. It's going to pull against that Achilles tendon and point the foot. Now, I try to not give you a lot of the detail that isn't as necessary as I normally do in regular lectures, but I feel like doing it here. So Achilles tendon, named after a Greek hero, Achilles. The idea is that these were real people. They were once just as alive as you and I are now. This was a real thing. So let's talk a little bit about it. Achilles, by all means, was probably a very fast person, and the idea is that during battle he was shot in the heel, okay, probably severing his Achilles tendon. And if you've ever known or seen someone who has had their Achilles tendon severed, the foot just kind of hangs limp. It's got no support of any form. So the guy probably got hit in the heel and was no longer able to move around and do anything, so he got rushed and killed. And thus, we now call this the Achilles tendon for posterity, simply as a result of that battle happening. Yeah, all right. So let's make sure we're together. Tensor fasciae latae, sartorius, muscles of the quadriceps. We've got our patellar tendon and quadriceps tendon is what I prefer to call that. And then patellar ligament down here. We've got our tibialis anterior and our gastrocnemius and our Achilles tendon. Talked about our hamstrings and our glutes. I'm pretty happy. So let's just go into here. This is last but not least, and we've already kind of played the game of the knee joint, but you may see it again, so I'm going to talk about it. On our knee joint, quadriceps tendon, patellar ligament. This would be a right leg, so this is lateral, lateral collateral, medial collateral, lateral meniscus, medial meniscus. I'm very popular. And then, if you kind of take this and turn it around backwards, you can see the, we call it posterior cruciate ligament. And if I kind of take it and lift it up from the front, inside of there, that would be the anterior cruciate ligament. So posterior cruciate and anterior cruciate. They are called cross-shaped. They are cruciate. I wish you could be here to see this, man. It's so hard to make out, but they form an X, okay? Posterior cruciate coming down like this, anterior cruciate going across like that. They form an X shape. And that is the muscle lab, and it's more than you think, so get to work on it. I'll be putting a quiz up on it real soon, and yeah, good enough. Get to work. All right, thanks, guys.